Okay, so let me share my screen. So if you can see the screen, say yes. If you cannot see the screen, say no. So can everybody see the screen, yes or no? Yes, okay. So let's start here, systems of equations. Lesson 2. Right, so today we're going to go over homework, free equation systems, and then nonlinear systems. So I think the only thing new here is nonlinear systems, which are pretty important later on, so make sure you pay attention. So let's start with the homework first. I'll give you a couple minutes to do this. Okay. Okay, so let's go over this one, if anybody has an answer. Okay, let's see who's here, who can volunteer. How about Dan Liu? Can you volunteer to help us solve this problem? Are you there? Dan Liu, can you come help solve this problem or not? If not, I'll just go over it. So this problem right here is elimination, basically. So let's look at this. What we can do is, there are a couple methods we can do this. We can do this with substitution or elimination. But if you look at the numbers, the coefficients of y here, you can see that basically what you can do is you can multiply the coefficients of y by 2 and add them to negative 10y. So 10y plus negative 10y is equal to 0. So then you cancel out the y's. So first, you need to do that. So multiply the second equation by 2, like so. All right. Then, when you add them using elimination, you can cancel out the y's. So let's add equation 1 and equation 2. We get 4x plus 0 is equal to 28. So x obviously is equal to 7. And y is going to be equal to, if you plug this in, 6, 7 plus 5y is equal to 2, right? So y is going to be negative 8. Okay, so if we solve this, let's change this. Put this over here, right? Easier to see. So 6 times 7 plus 5y is equal to 2. 42 is equal to 42 plus 5y is equal to 2. 5y is equal to negative 40. Y is equal to negative 8. So from these, we have the solution, and that is going to be 7, negative 8. Okay, so are there any questions on this? If there are no questions, then I will continue. So the next question is number 2 here, negative 9 plus 5y is equal to negative 4x, and negative 11x is equal to negative 20 plus 9y. So I'll give you a couple moments to do this, and then we'll come back. All right, so let's go over this one. So this one, what you need to do is, let's see here. So do I have any volunteers to do this? How about Kaylee?
Okay.
Okay. So how would you do this?
I chose to multiply the top by 11 and the bottom by -4. So I got -99 plus 55x, y is equal to -44x. And
What did
then,
you do?
uh,
Negative 99 plus 55, y is equal to negative 44x. Okay.
and
And
then 44x equals to 80 minus 36y.
okay.
And
So
then,
why don't we rearrange this first? So hold up. Let me rearrange this real quick. 44x plus 55y is equal to 99. And let me see. This is 44x plus 36y is equal to 80, right?
Mhm. Then we get 19y is equal to 19.
Okay, so y is equal to 1.
And then if we plug it in, x is also equal to 1.
Okay, so let's plug it in. Right, so yeah, both is equal to 1. So the answer here, 1, 1. Okay, very good. Nice numbers today. Okay, now the hard one. Well, not really hard, it's just tedious. Okay, let's go over this one. So this one is a pretty long one, so let's see how we do it here. Do I have any volunteers that would like to volunteer for this question? Andy? Andy, would you like to help?
Sure.
Okay. So
Add
what
the
do you think we
third,
should do here?
add the third and first equation, and then all you're
Uh,
left with is
yeah.
x and 5y cancel out, and this equals and then z is equal to 3. And then you have the last two equations, right? And then you can plug in z. Actually, yeah, you can plug in z, and then you have a regular system of equations, and then you can find and then you add them together. So the first equation would
Well,
be turned
actually, you can
into
just add it right now if you think about it.
yeah, you could add it right now, and then it would be
So
5x.
5x minus 3, well, plus 3z is equal to -1, and then you plug this in, right? So it's,
Oh
yeah,
no, we
same thing.
added them, right? Yeah. It'll do the same thing.
Yeah, hold on.
Yeah.
5x plus 10. No,
Yeah,
it's 5x is equal to -10.
yeah,
X
and
is
then
equal
x would be
to -2,
and then you plug
right?
it back in.
Okay, so this one wasn't too bad. Is this correct?
I think so.
Let me
So
check.
I think y is a good number.
Yeah, it's a cool number.
What? What did you say?
I think it's a good number.
Y is supposed to be a good number? Okay, hold on. Let's plug it into another equation, see if we're correct. So 4 to the times -2 minus 5y plus 4 times 3 is equal to 19. -8 plus 12 minus 5y is equal to 19. So -5y is going to be equal to... That's interesting. Okay, so apparently I was wrong on the first one. Y is equal to -3. So did you get that, Kaylee?
Yeah.
Who talked just now? Okay, yeah. Nice. -2, -3. Oh no, there's one more. And 3. Alright, so that's the solution for this one. Okay, so let's go continue our 3 equation systems, and I'll talk about more how to spot some methods on how to solve these things. So let's see how many slides we have here. Okay. Yeah, I have one slide of 3 equation systems, so let's just do maybe a few practice problems. Okay? And I want everybody to volunteer on these because these we already talked about this last class, so make sure you volunteer and do so. Okay? More participation. Right. So let's do 2x plus y minus 3z is equal to 5. X plus 2y minus 4z is equal to 7. 6x plus 3y minus 9z is equal to 15. Okay, let's do this one. So let's see the solution now. So who can help me on this? Jenny, are you there? Jenny? No? Okay, how about who wants to volunteer? Or maybe I call on someone like Dan Lu.
Okay.
Okay. So how do you think we should solve this?
You multiply the second equation by 2, so you can cancel out the x's. And
That's true. So let's pull these two equations out. And the first one remains the same, right? Right. So the first one remains the same. And the other one we multiply by -2. Okay. This one I forgot to multiply. -2, right? So it's minus 4y. Okay,
and then
so
we
then
add
we
them.
add them, right? We add them. So what do we get if we add them?
So wait, -3y minus 24.
Minus,
Wait,
minus.
oh, wait. Plus 5z equals -9.
Okay. Yep. So this
And
is what we have. And we can also do it for the second and the third, right? So if you go here, the third one remains the same, right? And this one we multiply by -6. Okay, so now we add. And what do we get if we add?
-9y plus 15z equals 27, -27.
Okay, so that's what you get. And we can actually take this down a notch and divide by -3. So 3y minus 5z is equal to 9. And what the heck? We got the same equation. That's funny. All right, let's see what happened here. We need another equation because these two are the same. So what do we suggest we do?
We do equation 1 and 3.
We could try that. Let's try that. So 1 and 3 we could try. So -6y. Basically, we're multiplying the first one by -3. -6y minus 3y. And then plus 9z is equal to -15. 6x plus 3y minus 9z is equal to 15. And these two cancel out. 0 is equal to 0.
Wait, so wouldn't this be impossible?
No, I think this one might be infinite solutions. Yeah, I think this is going to be infinite solutions. So let's see what we get here. I think we figured out that this one is going to be infinite solutions. So what we get is -3y plus 5z is equal to -9. And let's say we base this off of z. So 5z is going to be equal to -9 minus 3y. Z is going to be equal to -9 minus 3y over z. Yeah, that's not going to be optimal. Let's try y. Okay. So y is going to be equal to -9 minus 5z over -3. So this should be good. and we cancel out the negative. 9 plus 5z over 3. Okay. Yeah, so we know what y equals in terms of z. Now we want to find what x equals in terms of y, right? So let's see. I should have known this from the start because these two equations are basically multiples of each other. So you can't really have a solution in the first place. All right, so this is going to be one of those consistent but dependent type equations. So let's eliminate y. Okay, let's eliminate y. So the first and second, let's say negative 4x minus 2y, okay, plus 6z is equal to negative 10. Basically multiplying the top one by negative 2. And x plus 2y minus 4z is equal to 7. Add negative 3x minus 3z is equal to what? Negative 3. X minus z is equal to 1 because we divide off negative 3 everywhere. So basically, what we get is x is equal to 1 plus z. So now we know this. Now that we know this, y is going to be equal to 9 plus 5z over 3. And x is equal to 1 plus z. Our answer is 1 plus z, 9 plus 5z over 3, and z. That's the answer. All right, does everybody get this? This is the consistent but dependent type. All right, does everybody get this? Are there any questions? If there are no questions, then let's do another one, right? So this is called consistent and dependent. Consistent means that the equation, that the system has a solution. Dependent means that there's infinite solutions. Okay. So let's do another one here. We have 3x minus y minus 2x, no, not 2x, 2z is equal to 4. 6x plus 4y plus 8z is equal to 11. 3x plus 2y plus 4z is equal to negative 1. Right. So now we look at this. Okay,
No,
and
it's
what do we do?
inconsistent.
What?
It's inconsistent because the second and the third equations are pretty much the same except for the end.
Ah, that's true. Let's see. So what can we do to figure out? So that's who said that? Who said that just now? Was it Dan Lu or William?
It was me.
Oh, very good. That's a very good observation. So yeah, that's good. So what you were talking about is these two equations, right? So these two equations, and immediately it's inconsistent. Do you know why? It's because 6x plus 4y plus 8z is equal to 11. And if you multiply this, the third one by 2, 6x plus 4y plus 8z is equal to negative 1. This cannot be true, right? Well, not negative 1, negative 2. Because if these are equal, then you must set 11 is equal to negative 2. That's just not possible. So therefore, this system has no solution. Okay, no solution. Are there any questions on this no solution problem? Good observation, by the way. Very good observation. If there are no questions, then let's do this. Okay, let's go on to nonlinear systems. So what is a nonlinear system? It's when system of equations with conic sections, right? System of equations with conic sections, and I think you can do this with substitution or elimination. It depends really which like method is the best. So here are a couple of scenarios. So remember when we had linear systems, we had how many solutions? We had one solution at most, unless it was like special and had infinite solutions, right? At most we had one solution, right? That's a consistent and independent system. But now we can have multiple. So here are a couple of possible situations. So this is conic section and a line. So you can have an ellipse or a line, no intersection. This is no solution. Or we could have something like a line and a parabola. That's one solution. An ellipse or a line through it. That is two solutions. So the most you can have with a conic section and a line is two solutions. What about two conic sections? If you have two conic sections, you can have an ellipse and an ellipse, no intersection. What about two intersections? You can have something like what can you have that has two intersections? Maybe like an ellipse and a parabola right here. That's two intersections. What about three intersections? An ellipse and an offset parabola like this. One intersection, that's three intersections. Well, that's a hyperbola, technically. Or you can have what? Two hyperbolas. And that's four intersections. So the most you can have, right, for each of these is two solutions for conic section and line and four solutions for two conic sections. Great. So are there any questions on this? Yes. Oh, for hyperbola, for conic section and line? Let's see here. No. You actually cannot get 4 with the hyperbola and a line. Because you would have this. That's still 2. Right? So
Line can go diagonal and reach a side of the hyperbola.
what do you mean?
Like if you extend the hyperbola, And so the line is diagonal, so it reaches like the opposite sides of each hyperbola. Like,
Wait, can I try to draw it out?
Hold up. I see. That's funny. What are you implying here? The line diagonal hits. Oh, hold up. I think I know. Like if you have a really this one. So what are you thinking right now?
Can I try to draw it out?
can you give us
Really?
annotation access?
The axis? Okay, let me check. Let me check. I think this is quite interesting how you found 3. So you can annotate, right? Let me see. So can you annotate now? Okay, that's very good. So you can now annotate. Okay, let's see how you do it. Yeah, but you see, I understand your ideas here, but that's actually not going to be possible if you think about it. Hold up. Let me change the meeting settings again. So you need to look back to the what? The properties of the hyperbola. So let me share my video here. So a hyperbola, remember a hyperbola. This is, for example, this is the center. It's a vertex, foci, hyperbola. I think you forgot, because your hyperbola was quite roughly drawn, that there's an asymptote here. Meaning that any line that goes diagonally will only reach 2, because any line will only be tangent. You see this? A line can't go from here, and then hit somewhere like here. That's not possible. The most it can do is to go tangent with both of these, like this. If you draw a good, perfect hyperbola, this would not be possible, right? So if you draw the hyperbola correctly, following the asymptote, it would not be possible. Okay? Does that make sense? Are there any questions about that? If there are no questions, then I will continue with the nonlinear systems. Okay? But anyways, that is a very good observation as well. That made me think for a while. Okay, but remember that the hyperbola has asymptotes. So don't forget about the asymptotes, meaning that the line that passes through any of them will never actually intersect more than 2. Okay, so let's do some practice problems while we can. There is one practice problem that I would like to bring up that's pretty important. Let's first do this one first. It is y squared is equal to 13 minus x squared plus 4y squared is equal to 25. So I'll give you a couple moments to do this, and then we'll go over it. All right, so we have a couple of answers. That's good. So William, can you come volunteer and help me solve this?
Sure. So, I just moved x in the first equation. I moved x to the other side, so x squared plus y squared equals 13, and yeah, that equals 25. So I subtracted the equation, so I got -3 y squared equals -12, and y squared equals 4. So y equals plus or minus 2. And then I plugged a positive 2 into the second equation. So x squared plus 4 times 4 equals 25, which is 16. So x squared plus 16 equals 25. So uh yeah, so then y squared is just plus or minus 3. I mean x.
So we have 4 solutions, right?
Yeah.
Okay. Now let's go on to our next problem that is going to be quite significant. So make sure you pay attention to this one. This one needs to be solved a little bit differently. So try this one out. And I'll give you a couple moments. Okay, let's go over this one. So this one is not no solution, unfortunately. What you do is you have to factor this. My bad. I think it was no solution because I forgot to put the plus there. Um, okay, I missed the plus sign. All right, but anyways, the point of this exercise is to factor. So you have to get 2 times 2 x. Okay. No, not x times 2x minus y is equal to 0. So you get x is equal to 0 and 2x minus y is equal to 0. And y is equal to 2x. So basically, no, not necessarily. This one's kind of weird, isn't it? So you cannot actually solve for y like that. You have to go back to this. You have to go back to that and then solve for that. So if x is equal to 0, then y is going to be equal to, let's see here, plus or minus 3. If x is equal to 0, plug it into this one. This one is very weird, by the way. Yeah. Let's see here. No, I think y is equal to 0. Y is equal to 0, right? Let me go on Desmos and see if this works. So on Desmos, we can actually, the graphing calculator, we can see where the intersection is. I don't know where I got this problem from, but it was quite trippy. So I thought I'd talk about it. But let me go on Desmos and so basically the first equation is an ellipse and the second one is a line. So there's two intersections. Okay, so there's two intersections. So I don't know which one works actually. No, there's actually, oh, I see, because y is equal to 0 is not a solution here. Let's see why this is. I think it has to do with the I think this has to do with the factoring, because the factoring and all this squares cause extraneous solutions. So I think the main idea is here is in nonlinear systems where you factor like this and you just take the factors like x is equal to 0 without solving for it, you have to check your answers for extraneous solutions. So I think this is well, not necessarily actually. Let's check this again. So we got 0 plus or minus 3 and then something else. So when this is difficult, isn't it? X squared minus xy plus, whoa, that's a lot of extraneous solutions. So I don't think this one works either. Damn. Huh. That's interesting. Okay. Let me rethink this. So if we go on Desmos real quick, let me change my screen. If you go on Desmos and we look at the solution, it's an ellipse with a line through it, but the answers are not 0 and plus or minus 3. It's quite weird. So let me share my screen now. it's this. So x squared minus xy plus y squared is equal to 9. Okay? And x 2x minus y is equal to 0. I actually have no idea how this works. When I did it, I thought the answer was 0 and plus or minus 3 without checking the answer. But apparently it is not. So see the points of intersection, this is quite weird. That's, I think, so the x value is actually completely incorrect. That's funny. So this would be approximately 1.7 is square root of 3, right? I have no idea. Okay. Well, class is ending anyways, so I'll look into that. Okay, I'll look into that. I don't know what happened with this weird problem, but since there is an intersection, there definitely is a solution. Just don't know how we are supposed to get it. I think the method is definitely two-factor here, but it is not. The solution is not correct. So I'll look into that. But I think that's all we have time for today. So yeah, I'll see you guys next time, and I'll post the homework very soon. Okay? So yeah. Yes? Who is that? No, okay.
Bye, thank you.
Bye, thank you.
Goodbye.